Okay. Hello, everyone. I'm happy to make a presentation about this specific scope of research. So my name is Yonghan Kim. I'm a PhD student from the Technical University of Munich. This project is a part of a very another big research topic. It's a figure over automatic code compliance checking. So what I want to discuss in here is about more like how can we process figure inside the regulatory documents to make multimodal large language models life more easier. So this is the motivation. So the motivation is quite straightforward. We would like to tackle down the elephant in the room in the ACC domain, which is the figure inside the regulatory documents. So most of the automated code compliance checking research have been highly focused on the texture-based rule interpretations. However, the figure itself, it has quite a big portions of figure exist in the requirements, and they're embed very important information that we have to interpret for more accurate automated code compliance checking. So I think this one is the very good examples of the what would be the important example information that we have to retrieve. So when it comes to a distance measurement, it has some very fuzziness inside in here. So maybe there are some extra term can explain about the distance, maybe net distance. There can explicitly explain about where should we start and end the measurement itself. But however, most of the textual regulation inside representing distance time to time provide figure to make the information more explicitly. So at this point in this strict framework, the multi-large language model can interpret the both modality of the normative knowledge, and it has to reasoning about what kind of proper tools to be executed to make a perform the distance-based measurement compliance checking. So however, the composite figures makes problem. I think you might have heard about the term, the picture words 1,000 word. So I think that's the problem. So the figures, when it comes to just provided into the ChatGPT, it might have some problem. It can sometimes misinterpret the original rule intent, and sometimes it just miss the information inside the figures. So that's why we need to pre-process this figure to make multimodal large language models life more easier. And we don't want to discuss about the fine-tuning approaches because it is tedious job when it comes to the Tanya blocks works. You have a lot of effort to annotate the portion of information inside the figure, right? So we want to discuss about the zero-shot approach. So for the state-of-the-art approach for this specific topic would be our best colleagues and our vicious nemesis on our research is the ChatGPT. Just let ChatGPT to isolate the specific portion of information inside the figure and let them generate more clean image out of it. So however, there are some challenges inside here. Because of the nature of this ChatGPT API-based image generations, it creates image from the zero base based on what conditions embedded into the prompt. So they might have some portion of the difficulties of losing the original intent of the regulated document. So the question is how can you decompose each graphical rule to express one rule without any training and pair it with the textual rule while preserving the original graphical rules intent? So this is the overall our proposed method here. So the overall method starts from the rule extractions. We need to extract figures and the textual provision from the PDF version of the regulatory documents. And then for the figure, we applied the segmentation anything model, which is the open vocabulary foundational model for the segmenting the object inside the model. We applied several prompts, texture prompts to identify errors and guidelines and texts, and we merge it into the single masks. And after we removed every mask to make these general clean base images. And after that, we group the mask into distance-based clustering and let the annotations appear one by one. And then we finally created the figures with single rules inside. And not only just for the figures, the texture rules also have a composed information in here. We utilize just the chain of prompting to make the single provisions to make 3 different regulations in here. And after that, we use the semantic embedding based pairing by the clip to match which one is paired with specific figure and texture atomic rules. So for this experiment design, I would like to evaluate how good at my proposed method in the context of the figure decompositions. So for the data set, we collected 48 composite graphical rules from 2 different regulatory documents. And I just simply manually decompose the example by the labeling, where is the annotations, how can I erase it, and collecting the 134 atomic graphical rules in it. And for the compare the approaches, we compare with the zero-shot multi-large language model utilizations, which is the ChatGPT and my proposed method, and evaluation strategies to evaluate with the multimodal large language model as a judge with the 2 different criteria. So it has only a single requirement, and it is same as a ground truth. And when it comes to the meaning of the same as ground truth here, we decompose the graphical rule in the single requirement, and it has original intent inside. So I would like to just let multi-large language model interpret the 2 input images. One is the ground truth, one is the generative output, and compare it whether it has the same meaning of this image. So this is the experimental result. As you can see, baseline shows a very robustness for isolating a figure. It can 100% up into a single rule. However, the baseline, which is the ChatGPT-based API image generations, produced some dialect representation cases of the original intent of the figure. I will discuss it in the next slide. And the proposed measure showed slightly better than the baseline while preserving the original intent of the figure. So when it comes to for the downstream text of the meaning of the decompositions in the figure itself, we checked the previous research on this specific React agent-based framework. The decomposed figure actually make multi-large language models better, but it has a slightly large amount of effort to make it better. And this is for the discussion about the image generation part. So right side is the original graphical rule input, and the left side is from the proposed method, and this is from the baseline. As you can see, it can isolate it in the very single requirement, and it looks very clean. And time to time, our proposed methods fail to isolate the annotation itself and just blurring the random part of the explanation. However, we have very good successful cases and some failure cases of the ChatGPT. As you can see, from the baseline, it loses the original intent of the distance measurement, which is a very critical issue when it comes to deterministic automatic code compliance checking. So this is for the conclusions. We just simply explore the zero-shot approach to decompose figure and texture rules for the multi-large language model-based automated code compliance checking. There are some limitations on the annotation isolation. There are still reliable, especially for small or low resolutions annotations. And we were definitely making it better. And we would like to extend this research toward the end-to-end figure-aware automated code compliance checking pipeline with broader figure types. And I would like to thank the Hans Fischer Fellowship Program of TUM and the Georg Nemetschek Institute to support this research. And thank you for your attention. And I would like to take questions if you have any. Thank you.